Hey, this is Luke, and in this video we're going to take a look at the 2010 AP Statistics exam, question number 2. A local radio station plays 40 rock and roll songs during each 4-hour show. The program director at the station needs to know the total amount of airtime for the 40 songs so that the time can also be programmed during the show for news and advertisements. The distribution of the lengths of rock and roll songs in minutes is roughly symmetric, with a mean length of 3.9 minutes and a standard deviation of 1.1 minutes. Part A, describe the sampling distribution of the sample mean song lengths for random samples of 40 rock and roll songs. Part B, if the program manager schedules 80 minutes of news and advertisements for the 4-hour, 240-minute show, only 160 minutes are available for music. Approximately what is the probability that the total amount of time needed to play 40 randomly selected rock and roll songs exceeds the available airtime? So let's take a look at the model solution for this question, and then we'll look at the rubric that was used to grade it. Now, starting with part A, it says describe the distribution, which we know from previous videos means that we need to make sure that we address the shape, center, and variability of the distribution. And so I've started by simply putting the information that's given in the problem about the population distribution of the lengths of songs. But then the question asks us about the sampling distribution when taking samples of 40 songs. So the first thing that we notice is that the shape is going to be approximately normal because the sample size is greater than 30 and the central limit theorem applies here. We know that the mean of the sampling distribution is going to be the same as the mean of the population at 3.9. And then for the standard deviation of the sampling distribution, we know it's the standard deviation of the population divided by the square root of n, which gives us our 0.174. Now, moving on to part B, we want to find out the probability that the total length of the 40 songs is 160 minutes or more. So what I've done here first is I've taken that statement and turned it into an average song length. So 160 minutes, there are 40 songs. That would be an average song length of 4 minutes. And really what we're trying to find is the probability that that average would be greater than or equal to 4. So now this just turns into a normal distribution calculation. And I've taken my mean and my standard deviation from what we stated in part A, and we want to calculate the probability of getting an average of 4.0 or greater. So we've gone through a z-score calculation and then gone to table A in order to turn that into an area, which gives us our final solution of 0.2843. Now also notice that this same calculation could have been done on the calculator using the normal CDF function, which would have given us the same answer. Now, one quick thing to point out about this question is that part A is necessary in order to complete part B. And this is very typical on the AP exam where they sort of lead you through some steps. So you can anticipate that there will be several questions where you'll have to use your answer from part A to be able to answer the question from part B. Now, on another note, if you get stuck on part A and you really have no idea what you're doing, simply make up some numbers here for a mean and a standard deviation and carry those down here, because you can still get an essentially correct in part B even if your answers from part A were incorrect. So now let's take a look at the rubric that was used to grade this particular question. And it's graded in 2 parts, part A and part B. So we'll start with part A. And for part A, there are 3 components which are necessary in order to get full credit here. The first component is to identify the shape as being approximately normal. And you'll notice here that I've underlined the word approximately. So it is not okay here to say that this distribution is normal. You have to say that the distribution is approximately normal. The second component that's necessary is to identify the center at 3.9, which we've done here. And then the third component is to identify the standard deviation with work. So not only are you identifying the correct standard deviation, but you've somehow shown the numbers that you used in order to calculate that standard deviation. Now, one note about part A is that if anywhere in your solution for part A you have incorrect notation, then the highest you could earn here is a partial credit. And where we most often see that is in the standard deviation formula. If you used S instead of sigma, that would be incorrect notation, because this is really a population standard deviation not a sample standard deviation. In that case, the highest that you could earn in Part A is a partial credit. In order to get essentially correct, you'd have to have all three components. Now let's take a look at the rubric for Part B. In order to get essentially correct in Part B, you have to have a correct setup along with the correct answer. So the correct setup here is our picture and our z-score calculation, and then of course our correct answer is 0.2843. Now here's where you might run into a scenario where you get partial credit. The first case is if you have the correct setup but an incorrect answer. Now most often what that's going to mean is that you set the problem up right, maybe you calculated the right z-score, but you gave this area as the answer because you forgot to subtract that from 1. That would be a partial credit because you have the correct setup but an incorrect answer. Now the other way you can get partial credit is if you have the incorrect setup but a plausible answer. Now most often what that would mean is that you maybe calculated this value incorrect in Part A, but you carried that down and then you did everything else in Part B correct based on that wrong answer. Well, that would be an incorrect setup because your formula for the standard deviation was wrong, but you still have a plausible answer based on that. So that would be considered a partial credit. And of course, incorrect would be incorrect setup and incorrect answer. Now I do have a note up here about the calculator command. You can, in fact, get a full credit, essentially correct, by using the calculator command normal CDF here, but you're going to have to make sure that you have labeled each one of the arguments that you're using in your calculator here in order to get full credit. Now, once you've gone through Part A and Part B and you have your essentially correct and your partially correct, you have to